Welcome to the deep dive. Today we're getting right to the core of high-speed networks. We're talking about the foundational hardware that, actually splits the fiber pipe. Our subject is the Thor broadcast F-PLC-1x4 fiber optic coupler.
Yeah, this is really about decoding the backbone of how our data gets delivered. At its heart, it's just an optical splitter. So you have one light input, and it gives you four outputs.
Sounds simple enough.
It does, but the engineering here is genuinely impressive. What immediately jumps out to me is the insertion loss.
Only 4 dB, right? I saw that.
Exactly, only 4 dB. And to put that in perspective for you, that minimal loss is like, well, it's like splitting a stream of water four ways and losing barely a drop. That kind of efficiency is absolutely critical.
So that brings us right to the technical specs then. I mean, okay, it splits the signal,
Right.
but how does the manufacturer guarantee that the quality doesn't just fall apart?
Well, you're looking for two things, really: uniformity and stability. The low insertion loss tells you it's efficient, but you also need something called low polarization dependent loss, PDL, right? And what that does is it keeps the signal from getting degraded or, scrambled if a cable gets twisted around during an installation.
So it's about reliability in the real messy world.
It's all about reliability.
Yeah.
And speaking of the real world, the durability promises here are, wow, this thing is built to survive some extreme conditions.
How extreme are we talking?
We are talking a staggering negative 40 degrees Celsius, all the way up to plus 85 C. That is just a massive promise of endurance.
Okay, let's unpack the next hurdle, which for me is always the confusing array of connectors, this alphabet soup. The source mentions four widely used ones: LC, SC, ST, and FC. What are the actual functional differences we should care about?
It really just boils down to how you plug it in and how much density you need. So the most popular choice right now is probably the LC connector. It's physically the smallest.
So that's for high-density racks.
Exactly. It's perfect for those. And it uses a simple snap-in connection, very quick.
And the SC.
The SC is more of a standard size, but it also features that quick snap-in connection, very easy for patching.
Okay, so LC is small snap, SC is standard snap. What about the ST? That one looks different.
Yeah, the ST is distinguished by its unique bayonet twist lock mechanism.
So it's kind of like the fiber version of a specialized garden hose connector. Reliable, but maybe slower.
That's a great analogy, actually. And finally, you have the FC. That's the older screw-type connector.
A cure, I imagine, but losing ground.
For sure. It's just not as popular as the faster, denser LC and SC options. So the key takeaway is LC is small, SC is standard, and ST is the twist lock.
So we have this really rugged, low-loss 1x4 splitter. It's clearly a foundational piece of equipment. But why does this little box matter to you listening right now who's just trying to get a fast connection? Where is this stuff actually being used?
This is literally how fiber gets to your front door.
Ah.
I mean, this coupler is absolutely essential for all those acronyms you hear about, like PON, or its faster cousin GPON.
Passive optical networks.
Exactly. It's the core technology for fiber to the home FTTH and that whole fiber to the point infrastructure, instead of needing a dedicated fiber line from the provider to every single house.
Which would be insanely expensive.
Totally. You take one large capacity fiber, you use this box to efficiently divide that light signal, and suddenly it can serve four different buildings or neighborhood nodes.
It really shows the complexity isn't just the cable, is it? It's these robust components that have to handle the split and those extreme conditions. And we've established the value of this small 1x4 splitter is about $425.
But this brings up a really important question about scale, though.
How so?
Well, we know these couplers go from a simple 1x2 split all the way up to a complex 2x64. So if this small 1x4 unit costs over $400, what do the engineering and complexity look like for a massive 6x64 unit?
Which is listed at what, nearly $1,500?
Exactly. And that's the challenge of extending fiber reach, isn't it? Keeping that signal perfect is directly tied to the cost and complexity of handling that massive simultaneous light distribution. That's the multi-million-dollar balancing act of building out our modern infrastructure. Something for you to think about.